Hey guys, Kenna here. Today we're going to go ahead and talk about coal. So, this is the last of the three major groups of fossil fuels, and we'll go ahead and finish up with some nuclear energy before moving on to our next unit. So, let's go ahead and jump right in and take a look at coal. Essential questions. Number one, what is coal and what are the four primary types of coal? Aha, you didn't think there were more than one type, did you? Number two, how does carbon content relate to coal ranking and to its heating value? Number three, what is the major use of coal? And number four, what countries use the most coal, total and percentage wise? Okay. So let's start out by taking a look at this first question. Just what is coal when we go ahead and start getting down to brass tacks? So, coal is formed from the remains of land plants buried and exposed to intense heat and pressure for 300 to 400 million years. Okay. This is why it's a non renewable. It is a solid. So remember, oil is your liquid, natural gas is the gas. This is your solid. And it can be burned in power plants and industrial plants. It is probably the most abundant of the fossil fuel groups. And it, because of this, generates 40% of the world's electricity. However, burning coal is one of the largest sources of CO2, which is a powerful greenhouse gas related to global warming. And so the environmental impact of utilizing coal, even though it's readily available, is a big one. Coal was the major fuel of the early industrial revolution. We think about examples like the pepper moths, right, where it actually was damaging enough to the environment to change the tree color from the whitish bark with little black spots on it, because you think about things like alders and willows and stuff like that, to an almost gray black bark, which changed the colors of different animals as well. So, when we think about the modern age was really jump started by the high availability of this high energy resource. But we didn't think about the environmental impacts originally. And there is a high correlation between the location of coal resources and early industrial centers. There's lots of coal in Britain, so parts of Wales, Pennsylvania, Silesia in Poland, the German Ruhr Valley. These are all places where a lot of power was, okay, in terms of global cultural economic power, largely because they had great reserves of coal to power them. Now, there are three primary grades of coal, and we'll go ahead and talk about the types or ranks of coal here now in a second. And we're going to go ahead and rank them based on the amount of pressure, temperature, and how deep they are in the ground to determine what their uses are and how pure, I use that term loosely, the coal is. Okay. So we have four different types or ranks of coal. We have peat, which most of us would not even classify as coal, like, but it does burn well. And if you think about peat bogs in like Ireland, they used to actually grow this. They'd cut out big squares and use them like logs on the fire. It's not coal, but it's peat, but it's headed that way. But then the other ones that we do typically classify as coal are lignite, bituminous coal, and anthracite coal. And if we were in class, I could go ahead and show these to you. But they definitely have different feels to them. There's pictures here on the right, peat on top, and then you've got your lignite, bituminous coal, and anthracite. And so as you go down, they've had an increasing amount of pressure and temperature. And typically they're deeper under the earth to provide that temperature and pressure. So anthracite is going to be the most compressed, whereas peat is the least compressed. So peat is the sediment that forms coal eventually. It's typically brown, partially decayed plant fragments already found in it. Vegetation that typically accumulates more in wetlands, so your swamps, your marshes, peat bogs, like we were talking about before, or lakes. Um, Typically, it's areas where there's stagnant water, so there's little to no oxygen in it, which is going to reduce the decomposition rate, which is what makes it high in carbon for when we go ahead and start looking at the compression into coal. This is a slow renewable fuel. There are some parts of the world that actually use the peat as a fuel itself, It's not typically considered a renewable energy because most of the sources accumulate at a rate of about 1 millimeter a year. Okay, so that's peat. So now let's go ahead and take a look at lignite. So the lignite is softer than the other two types of coal, and it is possible that you'll still see some plant parts visible in there, but it tends to start moving to a darker brown into maybe a gray black, and it's more crumbly or sooty. Okay. This is formed under the compaction of peat when there are low burial pressures and temperatures, and is a low rank coal with a carbon content of about 40 to 60% dry weight. Okay. Then sometimes, depending on who you talk to, you'll start seeing a transition version in here somewhere between lignite and bituminous that they call subbituminous. And this is between lignite and bituminous coal. Carbon content is typically about the same as lignite, about 40 to 6 to 60% dry weight. Um, but it ends up being maybe a little bit darker in color, looking more like what we would traditionally think of as coal. Let's just skip over it kind of into our bituminous coal category. Now, bituminous coal tends to be pretty hard. It's slightly sooty, nothing like the lignite we were talking about before, and tends to start having a little bit more shine to it. You think about like the shine that's on a graphite pencil, for example. It may have layers to it, tends to be deeper buried, and because of that longer burial and deeper depth, you have higher pressures than lower coal ranks. This is probably the most abundant type of coal we have here in the United States, and this is somewhere from 46 to 86% carbon by dry weight. Okay. The last of the groups that we want to talk about is anthracite. Now, anthracite coal is the hardest of all of them, and it's more shiny coal with a almost silvery luster. It's fairly reflective. This is a metamorphic rock. So if we're thinking about sedimentary before, as your temperature and pressure gets to the point where it actually changes the structure of the rock, this is a metamorphic rock formed from bituminous coal at much higher temperatures and pressures. And as such, it is the highest coal rank with a carbon content somewhere between 86 and 98% carbon by dry weight. Okay. So as rank increases, so does the energy output. When you get to anthracite with that much higher carbon content, it has a much greater energy output than bituminous, than lignite, than peat. So the farther you go down the list, the more energy you're going to get out of burning the same amount. Why is that? Well, one of the big reasons is because water is expelled as the peat gets compacted from one form into the next. The, the plant material then begins to break down, and that will release natural gas, again, mostly in the form of methane, like we talked about previously. Um, and a bed of peat about 10 feet thick produces a layer of coal about 1 foot thick. So that's a lot of compression if you think about it, 10 feet down to 1 feet. And so if you're absent oxygen, so it's not going to decompose, all of that carbon gets compressed into a smaller area, which is why you can get more energy out of burning coal, anthracite coal, than you will after going ahead and burning peat. Okay. So here is an image that represents that. You can see it getting compressed and compressed and compressed. Pressure, heat, and time. And anthracite is the hard coal that's going to produce the most amount of energy with like 85 to 95% carbon. Okay. So we've lost a lot of the water in that process. So we start out with peat. Remember, peat is going to go ahead and be brown, partially decayed plant fragments. You can see a lot of vegetation in it, typically accumulates in swamps, marshes, peat bogs, as I mentioned, with stagnant water because we don't want to have that oxygen because it leads to decomposition. That then gets go ahead and compressed. We're going to squeeze out some of that water to a higher energy form known as lignite. This tends to be soft still, but darker brown, gray, maybe black, typically pretty crumbly and sooty. So there's a lot more pieces that break off as it goes. This is formed under compaction of the peat with low burial pressures and temperatures and is a low coal rank. The bituminous coal is harder, definitely harder, but it's still slightly sooty. It starts to have a little bit of a shine to it, a shiny luster, but it's not to the very shiny nature of anthracite. And so this is typically more like what you would see in the graphite on your pencil. It may have layers to it because it hasn't gone through the metamorphic process, but it's definitely buried deeper, longer, and much higher temperatures than lower coal ranks. This is by far the most abundant coal rank in the United States, with a carbon content that goes up to as high as 86%. And then we have our anthracite that we mentioned, which is our hard coal. And this one has been metamorphosized from bituminous coal at very high pressures and temperatures and is the highest coal ranking with 86 to 98% dry weight carbon. All right. So anthracite's going to be the most efficient to burn because you're going to get the most energy out of it. This is going to have the lowest amount of sulfur in it, and as such is the cleanest version of it. But as we mentioned, most of what we have in the United States is bituminous, not the anthracite. So when you hear this clean coal, even the anthracite, which is the cleanest version of coal, definitely still pollutes more than oil and way more than natural gas still. Bituminous is your medium grade, about 50 to 75% carbon content, which has higher sulfur content than anthracite. And as such, because it has less carbon and more sulfur, it's going to have more impurities and it's going to be less efficient. And so we're going to end up with a greater environmental impact here. Lignite is the lowest grade with only typically about 40% carbon content. It is the lowest energy because there is so much less carbon in it, and it tends to have the most sulfurous and most polluting form of coal. Okay. No matter how you shake a stick at it, though, the environmental costs of burning coal are high. You have severe land degradation to go ahead and mine to it, water contamination to get it to where you need to. The air and water are highly polluted when utilized, and the air pollution is really the biggest concern we look at here. Sulfur released is sulfur dioxide, which is a major pollutant. We'll talk about acid rain when we get into the atmosphere. Large amounts of soot leading to higher rates of smog and just dirty air in general. CO2, which is going to go ahead and increase climate change. And then the coal ash, which can fall back down and cause pollution in water or on land. Okay. So, like last class, when we went ahead and took a look at the reserves and production for natural gas, let's do the same for coal. And like before, these numbers are from 2014. It'd be nice to have newer numbers, but let's go ahead and take a look at it. United States has a lot of coal, and I think this is one of the big drivers to try and get us to use more coal as a power source. The problem with it, again, is it's incredibly bad for the environment. We actually have the highest. We're in the top three in terms of reserves. We don't use as much coal as China does. China actually is a very big user of coal. Um, and we actually saw a decline in the use of coal because energy needs were lower, et cetera. Businesses slowed down because of COVID. And you started seeing much improved air waterways in China during COVID-19 because of the decline in coal use. Um, Coal production versus coal consumption, China is outpacing itself. So it's using more coal than it's able to produce, which means it's going to start running into its reserves and it's going to have a harder time replenishing. The United States, you can see, is number two in both of those. And then in terms of coal production consumption, you'll notice that even though Russia has pretty high coal reserves, it doesn't make the top three in terms of production and consumption. And a big part of that is its emphasis on natural gas. Okay. So here's a map looking at the actual coal production. You can see coal production is pretty high in places like the United States and China. And then you have your secondary markets. You start looking at the former Soviet Union, Australia, South Africa. These are Canada. These are places that still utilize coal, but not to the extent in terms of its production as the United States and Canada. Now, I think it's valuable to go ahead and start looking at production by type. Remember, the cleanest coal is that anthracite, which is the smallest category here. 7% of world coal production in 2000 came from anthracite. A huge amount, 75%, was actually from the bituminous, which is cleaner than lignite, but it's not as clean as anthracite. And remember, none of them are that clean in the grand scheme of things. With lignite, the least clean of them, making up about 18% of coal utilized in terms of production. If we take a look at US, China, India, which are some of the bigger coal users, versus the whole rest of the world, you can see that our numbers have stayed pretty constant, at least when we start looking at consumption. In the last couple of years, you have seen a little bit of decline in coal use in favor of things like natural gas and oil, again, because of that environmental impact. And so global coal use is likely to decline very slowly because it's still such a readily available fuel source, but people are increasingly beginning to understand the negative impacts in terms of the environment. But if we think about what it's used for, we talked about the fact that oil is primarily used for transportation. Natural gas is actually a pretty flexible fuel used for a lot of different things. Coal is mostly used for electricity generation. That's its biggest use. If we take a look in terms of the use of coal as an energy source and for electricity generation, coal actually produces over half, at least it did in 1998, of the US electrical production. Okay. Now, that's not as high as a country, say, like Poland, which has about 96, 97% of its electricity produced by coal, but that's still a lot. And if you combine all of these together, that's a fair amount of coal still being used because it is primarily utilized to go ahead and produce electricity. So let's finish by taking a look at the advantages and disadvantages of coal. So the biggest advantage is supply. There is so much more coal available than most of these other resources. And it has a medium to high net energy. And it's very low cost when we don't include the environmental and health costs. So as long as you're not doing full cost pricing, coal's cheap. Okay. If we started making those utilizing coal pay for the environmental and health costs, coal would become very, very expensive. Disadvantages. The biggest thing is pollution. Okay. Severe land disturbances to get it when we mine it, major water pollution due to leaching, fine particle and toxic mercury emissions coming from the mines, emission of large amounts of air pollutants when it is used and burned. So the advantages are that it's cheap and available. The disadvantages are the environmental impact is pretty major. And so, of all of our energy sources that we have in the US and globally, this is probably the most damaging to our environment. Okay. All right. That's what I've got for you today, guys. Take care of yourselves, stay healthy, stay safe, and I'll see you soon.